बच्चों, good evening. Welcome to 5 minutes physics. So in this lecture we'll discuss about total internal reflection. So क्या पॉइंट हम लोग डिस्कस करेंगे. पहले तो देखेंगे what is internal reflection. Then we'll talk about total internal reflection क्या होता है. What are the condition of total internal reflection. Like there are two conditions. The first condition is the ray must be traveling from denser medium to rarer medium. Point number one, the ray must be traveling from denser medium to rarer medium. That is the condition of TIR. मैं लिख रहा हूँ इधर रे मस्ट बी ट्रैवलिंग फ्रॉम डेंसर मीडियम टू रेरर मीडियम. डेंसर टू रेरर. ये डेंसर क्या होता है, रेरर क्या होता है. डेंसर मतलब जिसका रिफ्रैक्टिव इंडेक्स ज्यादा होता है. सेकेंड पॉइंट, सेकेंड कंडीशन इज द एंगल ऑफ इंसिडेंस मस्ट बी मोर देन क्रिटिकल एंगल. देन व्हाट इज क्रिटिकल एंगल विल डिस्कस इन डिटेल. एंड फाइनली विल डिराइव एक्सप्रेशन रिफ्रैक्टिव इंडेक्स ऑफ डेंसर मीडियम इज 1 by sin of critical angle. Okay, so these are the part we'll discuss. So without wasting time, we'll start the video. My name is SR Prusti and you are watching my beautiful channel Love You Science. So let's get started. So पहले देखते हैं internal reflection क्या होता है. Internal reflection का मतलब if light passes from denser medium to rarer medium at the interface, the light is partly reflected back into the denser medium and partly refracted to the rarer medium. So that is called internal reflection. देखो ये मान लो कि एक इंटरफेस है, ये आपका डेंसर मीडियम है, ये आपका रेरर मीडियम है. Let it is water and air. So whenever light, if light is passes from denser medium to rarer medium, then what will happen? The light is partly reflected back to the denser medium and partly refracted into the rarer medium. So that is called internal reflection. मतलब internally कुछ reflect हो रहा है. ये हो गया reflected ray, ये आपका refracted. Here ये angle of incident ray with respect to normal. ये refracted ray, ये normal. Angle is refraction angle. Getting my point? Next is what is total internal reflection. Total internal reflection मतलब if an entire amount of incident light will reflected, that is called TIR, total internal reflection, and that is applicable for certain condition. Condition क्या है? The angle must be more than critical angle. Now the point is what is critical angle. देखो ध्यान से देखो critical angle क्या है. Now if I increase the incident angle, the refracted angle also increases. क्योंकि as per the law of refraction, if light is traveling from denser medium to rarer medium, मतलब refracted light bend away from the normal. So now if I increase the value of I, then the value of R will also increase. Understood? For a particular value of I, that refracted light will be parallel to the interface, or you can say the refracted angle will be 90 degree. That corresponding incident angle will be critical angle. Are you getting my point? Again I repeat, if I increase the value of incident angle, the refracted ray also bend away from the normal. That means if I increase the value of angle of incident, angle of refraction also increases. Now I will find for a particular angle, the refracted ray will parallel to the interface, or you can say the refracted angle will be 90 degree. That corresponding incident angle is critical angle. Okay. Now, if I increase the incident angle little bit more or more than critical angle, then that refracted ray again it will bend. Understood? मतलब entire light will reflect towards the denser medium. So that is called TIR, total internal reflection. Is it clear? Now the point is, what is the relation between refractive index of denser medium and critical angle? Mu is equal to 1 by sin IC. That formula is very important, but we will derive this formula. So to derive this formula, we can have different observation. ये हो गया आपका इंटरफेस है, ये इंटरफेस. So ये denser medium and this side is rarer medium. Corresponding refractive index is mu1 and mu2. Let So in first condition ये आपका incident ray, ये refracted ray. In first case incident angle is 0 and refracted angle is 0, since incident angle is normal to interface or plane. Now the first point, if I increase the value of incident angle, see, if I increase the value of incident angle, the refracted angle also increases. This one is a refracted angle. Since you know ray is coming from denser to rarer, refracted ray bend away from the normal. Next, if I again increase the value of I, refracted angle also gradually increases. So that means for a particular angle of incident, the refracted angle will be 90 degree. Understood? That corresponding incident angle is IC, critical angle. Again I repeat, if I increase the value of incident angle, refracted angle gradually increases. For a particular incident angle, I'll find the refracted ray will be parallel to interface, or we can say the refracted angle will be 90 degree. देखो ये धीरे धीरे शिफ्ट हो रहा है, मतलब ये शिफ्ट हो गया. So what is refracted angle here? 90 degree. That corresponding incident angle is critical angle. Is it clear? Is it clear? Okay. Now इसको erase कर रहा हूँ. Now again, if I increase the value of incident angle little bit more or more than critical angle, so here I will be more than IC, then what about this ray? That ray will reflect. Yes or no? So here to TIR occurs, total internal reflection. मतलब entire light, entire incident light will reflect back to its original medium or denser medium. Is it clear? So मतलब in first condition में I is 0, in second condition I is less than IC, in third condition incident angle will be equal to critical angle, but in fourth condition, which is important, the angle of incident will be more than critical angle. That is the basic condition of TIR, most important. इसलिए मैंने बोला था दो condition है. First condition, ray must be traveling from denser to rarer, and second condition, incident angle must be more than critical angle. Clear? Now we'll derive this expression. See, you know, according to Snell's law, sin I by sin R is equal to mu2 by mu1, right? Then here, in this case, what is I? It will be IC. So sin IC by, what is R? R here 90 degree. So sin 90 is equal to mu2 by mu1. mu2 क्या है? Rarer medium, let it is air, मतलब mu2 is 1. And here denser medium, let it be mu, refractive index is mu. So matlab we can write down 1 upon mu. Is it clear? So sin 90 is 1. So sin IC will be equal to 1 by mu. Or we can write mu will be equal to 1 by sin of critical angle. So matlab refractive index of the denser medium is equal to 1 by sin of critical angle. So that is all about TIR, total internal reflection. I think it is clear to all of you. Okay. So hope you guys understood. Thank you so much for watching my video. Thank you. Thank you.